Hello everybody, welcome to Conceptual Physics. We'll give this another whirl, see if I can get this video to go. I know many of you have already seen me making mistakes here in class, so we'll see how it goes. So chapter 2 is where we're starting because chapter 1 is the same chapter in all the science books that you've had, for the last 5 years. So we're starting at chapter 1. So speed is our first topic of discussion. And yesterday I asked you guys if you knew anything about speed, and you said, well, yeah, it's how fast you're going. And I was like, yeah, that's right. We know what speed is, just like a lot of things we know in physics. The trick, though, is that we're going to try to put math to this stuff so we can make predictions. Okay, so the first thing is speed is just defined as measures how fast something is moving. And you knew that, right? Because if you're going faster in your car, you're going to get somewhere faster, right? So you got to think, why are you getting there faster? Well, because you're covering more distance in the same amount of time. Okay, so there it is. Our distance covered per time. So in a period of time. So if anything is like per time or in a period of time, that means it's called a rate. Okay, and so speed is a rate, and your formula for speed is distance over time. So that's supposed to be a t. The d got a little bit messed up there. Oh. Okay, so we got distance over time. Now here's the difference. There's another thing called velocity, and you probably heard of that too. And usually it's kind of used interchangeably, but speed doesn't have a direction, where velocity does. So speed is called a scalar quantity. So scalar, and that just means it has magnitude, but there's no direction. So for example, I'll show you the difference here between velocity and speed. If you have a car that's going in a circle at a constant speed, that's not a very good circle. You could say that, hey, this has a constant speed. So whether it's 30 miles per hour or 10 miles per hour, it can go at a constant speed. But that's because speed is a scalar. It has no direction as part of its description. If we were saying that this was velocity, though, what do you notice about the arrows here? They're all changing direction. Each moment, the car or whatever is traveling is going in a different direction. So it can be going at a constant speed, 10 miles per hour, but since velocity is a vector, it would be constantly changing because the direction is changing. So that's a big difference between kids don't usually come into physics knowing about velocity versus speed. So that's like your first thing that hopefully you're learning something different. Okay, so a car speedometer gives an instantaneous speed. So if you're looking at a graph of how far you're going and for how much time, so this x is kind of just a general term that's many times used for distance or displacement. So if you take off from home and you start moving, see that constant slope there? Okay, so you guys, do you know about slope mathematically? So it's the rise over the run, right? And if this was perfectly straight, it'd be called a constant slope. But notice how this x over this t, this x is actually standing for distance. So the slope of the line would be actually distance over time, the slope of this line. And so the slope of the line of a distance time graph is actually the speed. So what would you say, knowing what you know about slopes, what would you say about that portion of the slope versus that portion of the slope? Okay, so the question is, if you look at this, oh, I'm not sure why that disappeared, but if you look at this portion of the graph, how does the slope differ from this portion of the graph? What? It's not increasing, yeah. So, and this, I'm trying to draw it straight so it'd be a zero slope or no slope, which would mean in this case you're not moving any distance, so you have no speed. But here you've got speed because you're moving, your distance is increasing over time. Now think of this slope versus this first one. What do you notice about this slope right here versus this one? Yeah, the distance per time is higher, so that means that you're going faster here. You have a bigger slope on a distance time graph, you're going faster. Now I started talking about instantaneous speed here. And so if I was looking at all this graph, I'm going to erase a little bit here first. So if you look at this graph of distance time, so it's a speed graph, you notice that there's no like constant slope anywhere, right? And if you think of driving on your car, there's never a time that you're actually going like a constant speed. You're slowing up or slowing down or speeding up all the time, right? So when you, like, let's say that right at this time, you look at your speedometer, it'll give you what's called an instantaneous speed. And so if you wanted to figure it out mathematically, which I'm not going to ask you to do right now, you would have to take a tangent to the curve, and then that line, you'll have a slope value for that line, and that would be your instantaneous speed. So you should just know that when you're looking at your speedometer, you're looking at instantaneous speed. And what's the difference between instantaneous and something else? Well, the other thing that we have is an average speed. So if you would be going to Fargo, here's your total distance to Fargo, here's your time to get there, you go for a while, okay, you go for a while, and then you stop to go to the bathroom, and then you realize you got to get there faster, so you go faster. Well, you got to get gas. Yeah, probably, because you're driving a V10 or something like that, right? You can't get anywhere without stopping at a gas station, which is a nice, powerful engine. But anyway, so when you talk about how long it took you to go to Fargo, you would be talking about where you started and where you ended, and then you draw a straight line for that, and that would be called your average speed. Okay, so if you have average speed, one way to put it in formula is that line over the top. So it doesn't really care about when you're stopping and starting, going faster or slower. It just cares how you're going from the beginning to the end. So that's the difference between instantaneous speed and average speed. Okay, so this says an object with constant velocity will have zero acceleration. So now what you need to know is the definition for acceleration. Okay, so this note right here says slope on a graph would be zero because acceleration is zero. But it really should say slope on a velocity time graph. So you should put that in there, that it's not just any graph, it's a velocity time graph. So if you see your velocity changing here, I don't know why that keeps happening, then you're accelerating. Oops. But if you have a zero slope, you're still moving, but you're just going at constant velocity the whole time. Okay, so if you would see this portion of a graph on a distance time graph, then even though this is a zero slope for your velocity, you're still moving, and so you're at a constant velocity, which means your slope of your distance time graph is constant. This piece right here, though, that would look different. That would look like this. Your slope is increasing the whole time because you're getting faster and faster and faster. So it's the difference between a distance time graph and a velocity time graph. That's one of them. Okay. Okay, so these are just some common units of measure. So miles per hour is what you guys do in your car, right, for your speed. Light years per century is also a speed or a velocity. But notice they both have time in them. Kilometers per hour is what most of the world does besides America. There's speed limits. And meters per second is what we're going to use most commonly in our physics. So meters per second is the base unit for velocity in physics. Okay, so velocity, we're on to velocity. And like I said already earlier, velocity is a speed in a given direction. Um, Velocity is calculated the same as speed. The only thing I'd like to change though is instead of saying distance per time, because it's not, velocity is actually displacement per time. So there is a difference between velocity and speed, and the difference is distance and displacement. So it seems kind of weird, but if your track coach tells you to run 400 meters, you run around the track one time, right? And so if you run around the track one time, you ran 400 meters, that's the distance, but your displacement is 0, because displacement is the difference from where you started and where you ended. So there's a big difference between distance and displacement. There's a big difference between velocity and speed because of that. Okay, so constant speed could be including changing direction, but constant velocity, you cannot change direction and call it constant. So the difference here is that that velocity is in a straight line at a constant speed. And so with that said, it's just more redundancy. Changing speed or direction actually changes your velocity. Here's some examples. In a car, we can change velocity by stopping or stepping on the brake, which slows us down, pushing the gas pedal, which speeds us up, or turning the steering wheel. So we can maintain that same speed and just turn, and it's considered accelerating. Okay, so there's some formulas for you. So I'll write these formulas down. So like speed is distance per time. Velocity is displacement per time. And you can use x for anything, right? I could use x over here. It's just a variable. But x is pretty common as far as displacement, using it for displacement. Okay. Constant velocity has 0 acceleration, which means no turning, no speeding, no slowing down. You already have that in a note form already. A car going around a curve at 30 miles per hour will not have a constant velocity because the direction is changing, even though it has a constant speed. That's just a repeat of what we already talked about. Unit of velocity is measured in meters per second, and I told you that earlier, but now it's on here again. Meters per second is what you need to put. And see how it says north? So you actually have to put your direction in there when you're doing velocity. Kilometers per hour is okay.